We're going to be talking here about section 2.1, if-then statements and converses. An if-then statement, or conditional, is simply a statement that has a hypothesis and a conclusion, meaning we have some condition we're looking to see if it's true, and then we're making a conclusion based on that condition. So when we do these, we have if and a hypothesis, and we have then a conclusion. Right, the hypothesis is whatever follows the if, and that describes the condition necessary we're looking for. The conclusion is the outcome that happens when that hypothesis is present. An example of this would be the conditional statement, if it rains, then I will get wet. Our hypothesis is it rains. That's the condition we're looking for. The conclusion is I will get wet. Now, to be a conditional statement, it doesn't have to be true. Of course, we know that you might be inside and you might not get wet if it rains, but if we're assuming that this is true, then anytime we see rain, we assume that we will get wet. Okay. A converse of a conditional statement is found by switching the hypothesis and conclusion. So if the original was if P, then Q, P and Q, P representing the hypothesis and Q representing the conclusion, then the converse would be if Q, then P. An example of this can be seen here. If our conditional was if it rains, then I get wet, the converse will be if I get wet, then it is raining. Notice I don't have to say word for word what the hypothesis and conclusion were when I do the converse, but the ideas are what is switched. Now our condition is what used to be our conclusion, and our new conclusion is the condition. Oftentimes the conditional may be true and the converse may not be true. A counterexample is any example that shows a conditional statement to be false. Okay, so anytime we have a statement and one example is not true, then that statement is considered false. An example of a counterexample, if we look at the statement, if x is greater than 4, then x squared is greater than 17. This is an example of a conditional statement that can be proved false with a counterexample. We could say, here's one counterexample. If x is equal to 4.1, we know that 4.1 squared is not greater than 17. Or in other words, it's less than 17. So this counterexample shows that this statement is false. A biconditional statement is a statement made by combining the converse and the original statement using if and only if. So if we use the if P then Q as the original and if Q then P as the converse, then the biconditional would be P if and only if Q. Or you could say Q if and only if P. Many times in mathematics we use IFF to represent if and only if when using a biconditional statement. An example of a biconditional statement, from before we had the conditional if it rains then I get wet, and the converse was if I get wet then it is raining. And the biconditional, combining both those ideas into one statement, would say I will get wet if and only if it rains. Now in section 6.2 of our book, we will be dealing with inverses and contrapositives. The inverse is if not P, then not Q. You just negate the hypothesis and conclusion. And the contrapositive, you take the converse and the inverse, and you get if not Q, then not P.